Okay, so we have a circuit here, and we're trying to find Ix, and we're going to be using the node voltage analysis method. So we have 4 steps to this method. The first of them is to label all our extraordinary nodes and select a ground. So we have one here. Just a reminder, the extraordinary nodes are the ones with 3 or more components attached to them. So we'll just call this V1, label the voltage. Then we have one here. So we have 1, 2, 3, more than 3 components. We'll call it V2. And then we do have a third extraordinary node here, but we're going to go ahead and call this one ground because it is at the bottom, and that just makes sense. So our next step is to write out KCL equations for each of these nodes. So that means we want to write the currents like exiting the node. Just keeps all our signs the same way. So we see we have I1, I2, I3, I4, KCL equation, add them all together. Equal to 0. Over here, we'll label this I5, I6, I7, I8. Names don't really matter, just helps us keep track of everything. And now we're going to go to our next step. We're going to rewrite these equations using, Ohm's law and the given currents here. So let's rewrite this first one here. So I1, that's this current here, that can be rewritten as -2 because we know we have a current of 2 amps going in this direction, and I1 is opposite of that. So I1 can be -2. Let's see, I2 is this current right here. That can be rewritten as the voltage difference across this resistor divided by the resistance itself. So that will be adding V1 minus V2, since that's the positive minus the negative. Remember, we're going in the same direction as the current, divided by 12 ohms. Then we'll do that for, what is this, I3 right here. I3 is similar to I1. We have a current source going in the opposite direction. So I know that is not plus, that is minus 4 amps. Then I4, the voltage difference across here is V1 to ground. So V1 minus 0, we're just going to write V1 over 6 over here. Do the same thing for the second one. Let me just move. Oh, jeez. That's not going to work. Okay. Do the same thing for the second one. We start with I5. It is now going in the same direction as the current source. So we write it as just positive 4. Then I6, that's another one that's going V2 to ground. So we just write V2 divided by the 6 ohms. I7 is going in the opposite direction of this 3 amp current source, so a minus 3 amps. And then finally I8 going this direction, voltage difference from V2 to V1, so V2 minus V1 over 12. All that equals 0. the final step of this process is to solve this system of equations, because as we see here, we have two variables, v1 and v2, in both these equations, and we have two equations. That means it can be solved. You can do this any way you like, but I prefer matrices. So let me rewrite this, get it all in order. We're going to get all the v1s together from this first equation. So v1, we have a 1/12. That comes from this right here. We have a 1/6. Comes from this right here. Get all the v2s together. We have a negative 1/12. That's it. And then we're going to put all our constants to the other side. So that's +2, +4, 6. Okay. Now to do the same thing for our second equation, we're going to get our v1s together. We have v1 right here that is negative 1/12. Get all our v2s together. That is 1/6 plus 1/12. Notice it's very similar to the first equation, except we're going to bring all our constants to the other side. -4 plus 3, that ends up being -1. So this is now in a form where I can very comfortably open my TI-84 and get matricing. Let's see, this is a two variable system, two equations, so we're going to have 2 rows, 3 columns. Column 1 will be our v1, column 2 will be our v2, and the third column will be our constants. So v1 is 1/12 plus 1/6, v2 negative 1/12, constant 6, v1 negative 1/12, v2 1/6 plus 1/12, and negative 1. Now I can exit, go to math, get our reference, boom. So now we see that v1 is equal to 25.5 volts and v2 is equal to 4.5 volts. So going back to our equation over here, we wanted to find Ix, and Ix is this I8 term. They're equivalent since they're going in the same direction. If you'll remember, we rewrote I8 over here is this term. So we're going to rewrite it again, v2 minus v1 over 12, except now we can plug in our values. So we have 4.5 minus 22.5 all over 12. I really hate math. Let's get the calculator back. That is negative 1.5 amps. The negative sign just means the actual current with reference to Ix is flowing in that direction. So let's box our answer. Oh, just realized, made a mistake. This is not 22.5. I even wrote it over here. It is 25.5 0.5. So let's try this one more time. The actual answer is 1.75 amps. Alrighty, for real this time.